Everyone, myself Dr. Feroza Dimirajkar, and today we will see a 8051 program to find the cube of a 8-bit number. Now, what do we mean by finding the cube of a number? So, finding a cube of a number is multiplying the same number thrice. And let us consider here, we want to multiply or we want to find out the cube of FFH, which is a 8-bit number. So we need to multiply FF 3 times so that we get the cube of this number. And when we multiply FF 3 times, we get the cube of a number, and multiplying 3 times a 8-bit number, it means that the size of the result will be 3 times the size of the input. That is, it will be 24 bits. So we need to store the result at 3 memory locations. That is, we need 3 memory locations to store the result. So here the basic operation which is used is we are using the multiplication operation, and we will start by multiplying first FF twice, that is 2 times, as we cannot multiply all these together. So here I'll take first FFH. I'll multiply this with FFH. So the result will be FE01, and this is a 16-bit result. So now this result, it should be multiplied with again FF. That is a second multiplication. So here when you multiply this result, this result with FF, then you get the code of the you get the cube of the number, that is FD02FF. But the problem here we encounter is in 8051, we cannot multiply this FE01 directly with FF, because FE01 is a 16-bit number and FF is a 8-bit number, so it cannot be directly multiplied. Therefore, we need to split this 16-bit number into 8-bit number. That is, we have to perform 2 multiplications. First, we need to perform the multiplication of 01 with FF. So the result will be 00FF. Then we need to multiply FF with FE. Then we'll multiply FF with FE. So the result of this will be FD02. Okay. Then we will add the 2 results. So we will get what? FD02FF. That is, first we perform 01 multiplied by FF. The result we get is 00FFH. Then we need to multiply FE with FF. So here we will get the result as FD02. So we need to shift this FD02 to one position left, and then these 2 results must be added to get the final cube. Okay, that is the final cube of FFH. So here we have used a multiplication instruction. Okay, so we will use the what? We will use the multiplication instruction, that is mul-ab. This is the rule which is used for multiplication instruction, multiplication here. And when we are adding the middle numbers, we are always having a chance to get the carry here. So here we are using a multiplication operation, and when we when we are adding these two, the result of this multiplication and this multiplication, there is always a chance of getting a carry here in the middle one. Okay, so whenever we are adding these two numbers, we'll get a carry, and that carry has to be added to the result to get the final result. Okay, this FF will be kept as it is, whereas when we add these numbers, okay, now I have 00 and 02, so no carry will be generated. If at all there is a carry generated, that must be added to the next number, and then we get the final result. So here the rule which we are using for multiplication is mul instruction, that is MULAB. That is the contents of A and B are multiplied. So here the rule for multiplication is the two numbers must be in accumulator and the register B. And after multiplication, okay, once you multiply the contents of the accumulator and the register B, at that time the result, okay, so when you multiply these two, you'll be getting a 16-bit number. And here the lower byte, that is the lower 8 bit should be stored in the register, and the upper 8 bits, that is the higher byte, must be stored in the register B. This is the rule for multiplication. Therefore, whenever you get the output, here we are multiplying two 8-bit numbers, we are getting a 16-bit number. So this number, this is the lower byte, this will be stored in accumulator, and the upper byte will be stored in the register B. And again, when you are multiplying these two, FE and here FF and 01, so this will be stored in the accumulator and this will be stored in register B. Similarly, here FF is multiplied with FE, so here we are getting FD02. Again, FD will be stored in the register B and 02 will be in the accumulator. So here 8051, it has only one accumulator and one B register. So we need to use here additional registers in order to store the intermediate results in order to perform the multiplication. Okay, we will, just a minute. This was the rule for multiplication, and now this is the overall logic we'll be applying here. That is, here we will initialize the data pointers and the registers in order to perform the multiplication of the values. Okay, and which are stored in the memory, followed by a series of arithmetic operations. Okay, first we are initializing the data pointers, we are initializing the registers, then we will perform the multiplication and addition operations on that, and the results are stored back into the memory at a specified address. Fine. So what we are doing here, we are initializing the data pointers and the registers in order to perform the multiplication of the stored value, okay, in the memory, followed by a series of arithmetic operations. Then the results are stored in the memory at a specified address. Now here we will see the code with an example. The memory locations which I have considered here are 8000 to 8003. Okay, that is 8000, 8001, 8002H and 8003H. So we will give the input at 8000H. At 8000H we are giving the input as FF. So here at 8000 it should be entered as what? It should be entered as FF for the number which we want to find out the cube. Now this 8000, it is a 16-bit address. So the 16-bit address is an external memory and the pointer to it will be a DPTR. Okay, that is the data pointer here. Now the first step is to initialize the DPTR to 8000. So the first line of code will be what? It will be move, just a minute. Okay, so it will be move DPTR comma 8000H. Fine. Now here we have initialized the source pointer. Now we will take the content of this in the accumulator. So here the content of this should be transferred, should be copied to the accumulator. Okay, so for that we have used move x a comma at DPTR. Here we are using move x because it copies the data from the external memory. Now we'll copy the contents pointed by the DPTR into the accumulator. So here we have copied the contents of the dptr. Okay, contents pointed by the dptr into the accumulator A. Okay, here accumulator A. So now the accumulator will be having what? Accumulator will be having FFH. Now we need the second operand B. Okay, that is here. A is having FF. Now we want this FF in B also. So for that, what we will do? We will copy the contents. Okay, here we will copy the contents of A into B by using this instruction, that is move B comma A. Now so when we do the multiplication, what happens? We will lose the input number. Okay, so for that is we want ff for, like we want it for further multiplication also. That is we need ff again for the next multiplication. So what we'll do is we will keep the copy of ff in the ff, that is in the accumulator, into some other register, other general purpose register R1. So what we are doing, we are storing the value of A, that is FF, in some general purpose register. Say here we'll be using R1. So for that we have used, or I have used here, move R1 comma A instruction, where it will copy the contents of A to R1 for further use. Okay, then so now the data is in A and B. Okay, both the data are on datas are in A and B, and these are ready, and next we have to perform the multiplication. So what we'll do, we will use the multiplication instruction, that is mul AB. So it will multiply the contents of A and B. So once this instruction is executed, what happens? We get FE and 0, 1 as the output of this multiplication, that is FE 0, 1. So here 0, 1 is in A register. Okay, and FE will be stored in register B, that is 0, 1 will be in the accumulator and FE will be in the register B. This is the higher byte and this is the lower byte. Now we need to perform next multiplication, that is multiplication of 0, 1 and FF. To perform the multiplication, one of the operand should be in A. So one operand we have in A, that is 0, 1 we have in A. Another operand is also in A, but another operand should be in B register. So we will copy this in B register. Okay, we will copy the value of this in B register. That is, we want to copy FF in the register B. Okay, which is stored it is temporarily stored in R1 to B register. Now, but here you can see B register is having FE. Okay, if we want to perform this multiplication, what we have to do, one operand should be in the accumulator, another operand should be in the register B. But already B is having FE, and this is the important data, and here we don't want to lose this data because it will be needed for next multiplication. That is, we need to multiply again FE and FF. So what we'll do is we will save this data. So we need to store the contents of B register into any of the general purpose register. So what I will do is we will use register R2. We will store the content of register B into the register general purpose register R2. Okay, so here what we have done, move R2 comma B. The contents of B are moved into R2. So now we have saved the contents of B into register R2. We can now load what? B with FF. Okay, so what we'll do here, move B comma R1. So R1 is having what? R1 is having FF. Okay, so we will copy the contents of R1 to B. Now B will be having FF. Okay, now what we have to do, we have to go for the next multiplication operation. Okay, now our contents are 0 A is in A, 0 1 is in A, and FF is in B now. So we need to perform the multiplication operation. So here we'll execute MUL AB. So once the second multiplication instruction it is executed, the new result will be what? It is 00FF. So FF will be stored in A and 00 will be stored in B. Okay. Now here what we'll do, this FF, if you see the lower byte of this, okay, here this FF, it don't need any further calculation or processing here. So what we'll do, we will store this in the memory location. So what we'll do is we'll store FF at 8003 location. Okay, so what we'll do, we will initialize the dptr to 8003 by using move dptr comma hash 8003. Sorry, it should be 8003. By mistake I have typed here 9, it should be 8003. Then after that the accumulator, okay, accumulator is having ffh, which can be directly used for multiplication. Now here next is we have to do the multiplication of FF with FE. Okay, so here now FE, here A is in FE. Sorry, FF is in the accumulator. One of the operand is in the accumulator, but B is having 00 now. Okay, so this data, this is also important. Now this has to be moved to another register. Say we will take it as R3. Okay, so this data is also important, that we have to store in R3 before moving this FE, which was in R2 to B. So what we'll do, we will move the contents of B to the register R3. So here we are using what? Move R3 comma B. Okay, then what we will do, we will move the contents of register R2 to B. That is, you want to move FE to B register. So for that we are using the instruction move B comma R2. Okay, here. Okay, after that move A comma R1. Okay, so A is having what? A is having FF, we'll move it to R1. So now A is having FF and B is having FE. We will multiply these two. Again here I have made a mistake. It should be MUL. It should not be MULT. It should be MUL. So here we will multiply these two, FE and FF. We will get what? We will get FD02. Okay. So here we are getting FD02. Then once that is done, now we have got all the partial products. Okay, so here this 00FF we have got, FD02 we have got. Okay, now we have to perform the addition operation. Fine. So the rule for addition is destination must be an accumulator. Okay, so what we'll do is we will add the first addition. Okay, that is, the first addition will be between the contents of A and R3. Okay, R3 is what? Now we have said this in R3, so I have marked this as green. Earlier here this was in B, so because we wanted to multiply these two, we have stored this into the general purpose register R3. So now we need to add these two. Okay, that is 02 and R3 we need to add. The contents of R3 we need to add. So what we'll do is we will use the instruction add A comma R3. Okay, now the result of these two is 02, which is in the accumulator, and it has to be stored at 8002. Okay, so it has to be stored at 8002. Now the dptr, it is pointing at 8003, which is here 8003, it should be decremented to 8002, but as we don't have any decrement DPTR instruction in 8051, instead what we'll do, we will use decrement DPL. That is the lower byte of the DPTR, it will be decremented, and so here 8003 will become 8002. Okay, here decrement DPL. Then what we have to do, we have to store the contents of 8002 in the accumulator using the move x at dptr comma a instruction. So now 02 which was in the accumulator will be stored at this location. Okay, now we should add one more addition. Okay, one more bit is left here, that is fd. So for this we will add the contents of register b. Okay, b consists of fd here. Contents of register B with what? With 00. Actually here there are no contents. Okay, here there were no contents. We have only 00 and FF. Here there is no data. But uh, we will add this. We will just take 00 here. For that we have taken here move a comma hash 00h. Okay, we will assume that the accumulator is having 00h. So we will execute the instruction move a comma hash 00h. So now the accumulator will be having what? It will be having a, and b is having fd. So next what we'll do, we will add these two. Okay, so again here what we'll add, we will add fd and 00. Okay, so here we are adding the contents of the accumulator with the contents of b along with the carry which will be generated here. If at all a carry is generated, then it has to be added with that. So here we have to add fd with 00. We will get fd. Okay, so now this result, it has, so the result of these two, the addition of these two, it is stored in a, that is accumulator, but it has to be stored at this memory location, that is 8001h. Okay, so what we'll do, we'll use again the instruction, sorry, first we have to decrement 8001 to 8000, sorry, 8002 to 8001. So again we cannot write decrement dptr, so we will use what? Decrement dpl. Okay, so here decrement dpl, it will decrement the this memory location by 1 and will go to 8001. So here the content of the accumulator, that is fd, it will be copied to this memory location. So we are having the result as ff02fd. So this is our program. Now we will see the breakdown of the program here. Here first what we have done, we have done the initialization by using these two instructions. Okay, here I have written 9000, but in the program we have used 8000. It is your choice, you can write you can take any memory address. So here org 0000h move dptr comma hash 9000. So the program starts at an address 0000h, and the dptr, that is the data pointer, it is initialized to point to the memory address 9000. Okay, so the program is starting and we are initializing the dptr. Next what we are doing, we are using these three instructions, that is we are loading the value into the accumulator. So here this instruction, the move x a comma at dptr, it will load the value from the memory location pointed to by the dptr, that is the 9000h we have used, into the accumulator. Okay, and then the value of a, it is copied to the register b, here move b comma a. Okay, then again we will copy a to register 3. Okay, then we will perform the next that is the first multiplication. For that we have used these instructions mul ab and move r4 comma b. So here what it will do, it will multiply the contents of a and b, and then the lower byte is stored in A and the upper byte is stored in B, and then the upper byte it will be moved to R4. Okay, so here we are executing the multiplication instruction. Then we are storing the result in A lower byte, we are storing the upper byte, that is the higher byte, in B. Then we will transfer the higher byte to R4. After that we will perform the second operation. So second multiplication operation, and we will store the intermediate result. So here the value in the R3 it is moved to B, and then we perform the multiplication operation. Okay, then after that here move dptr comma hash 9003. Here we are updating the dptr. Okay, so the dptr it is updated to 9003, like 9003h location, and the current value in A, okay, that is the result of the second multiplication, it is stored at this address. And then the higher byte of the result from this multiplication it will be stored into R2. Here move R2 comma B. Next is the final multiplication. So here the value of R4 it is moved to A. Okay, and then the value of R3 will be moved to B, and we will multiply A and B, A and B, and then once this is done, we will multiply the contents of register R2 with A, that is add result to R2. Now we'll store the final result. So here the lower byte of the data pointer it is decremented to point to the previous memory location, that is 9002, and the final result in A is stored at this new address. Okay, then the accumulator A is cleared. Okay, that is we will load the accumulator with 00h, because for addition we need we need the accumulator also. So the accumulator will be loaded with 00 value, and then we will add the contents of the register B and A along with the carry. Okay, here we'll add that. Then decrement dptl. So again we'll decrement the data pointer again, and the final value is stored in this memory, and we'll end the program. Okay, so here it is clear the accumulator. Clear the accumulator is we don't have any value in the accumulator there, like here I'll show you here. Okay, now we have fd in B and we don't have another value. So here what we are doing, we are loading the accumulator with 00. Here move A comma hash 00h. Okay, so because of that it is there, it has been taken, it has cleared the accumulator. Okay, and we will add these two along with the carry which is generated, if at all, in the previous addition. Okay, so this is your program. Here what we are doing is first we are starting our program with org0000h. So this directive, what it will do, it will set the program starting address to 000h, and the program execution will begin from this address. Then move dptr comma hash 8000h. Okay, so here the data pointer is loaded with the address 8000h, and this is the starting address for accessing the external memory using move x instruction. Then we have move x a comma at dptr. So here the value at the memory address stored in the dptr, which is 8000, it is read into the accumulator A. Okay, then we have move B comma A. The value in the accumulator will be moved or copied to the register B. Then we have move R3 comma A. The value in A is stored into the register R3. This will be used later in the calculations. Okay. Then we have mul AB, that is the multiplication instruction. It will multiply the value in the registers A and B, and the result is stored in A. That will be the lower byte will be stored in A, and the upper byte, that is the higher byte, will be stored in B. Then we have move R4 comma B. So here the high byte of the result from the multiplication that is in the register B is copied to the register R4. Then we have move B comma R3. So the value in the register R3, that is this step, it is copied to prepare for the next multiplication. Then we have mul AB. So the values in the registers A and B are multiplied again, and the result is stored in A and B with the lower byte and the higher byte respectively. After that we have move DPTR comma hash 8003H. So here the DPTR is now loaded with the address 8003, and this is the new external memory address where the data will be written. Then we have move x at dptr comma A. So here the value in the register A, that is the low byte of the previous multiplication result, is written to the memory location 8003H. Then we have move R2 comma B. Here the value in B, that is the high byte of the result, is copied into the register R2. Then we have move A comma R4. Here the value of the value which is there in the register R4, which was stored previously, that was the high byte of the multiplication result, is moved into the register A. Then we have move B comma R3. So here the value in the register R3, it is copied to the register B, okay, to prepare for another multiplication. So next is the multiplication operation. Here the values in the registers A and B are multiplied again, and the result is stored in A and B registers with lower byte and the higher byte respectively. Then we use the add A comma R2 instruction. Here the low byte of the multiplication, the multiplication result, that is in the accumulator A, is added to the value in the register R2, which will hold the previous high byte of the result. Then we use the decrement DPTL. So here it is a data pointer low byte. It is decremented, and we'll move the data pointer to the previous memory location, that is 8002, and move. Next instruction is move A comma hash 00H. Here we are loading the accumulator with 00. Then we will use the instruction add C A comma B. So here the value which is there in the register B, which holds the higher byte from the previous multiplication, is added uh, to the contents of the accumulator along with the carry, if at all it is generated from the previous addition, and the result is stored in the accumulator. Now again the DPTR is decremented. Sorry, the lower byte of the DPTR is decremented by using this instruction decrement DPL, and now we will be having the address as 8001. Next we have to move the result of this, which is in the accumulator, to the memory address 8001. So we will use move x at dptr comma A. Okay, so this will here the final result, okay, the final result which was in the accumulator A, it is been returned to the memory address. Okay, and then we will end the program. So here we will give the input at 8000H location. Because it is an external memory location, we will take it as x colon 8000. We will give the input as ff, and we should get the output as, this was the input, output is ff02fd. So at 8003 FF will be stored. Okay, here, sorry, this will be stored at 8003, 8002, 8001. Okay, so FF02 FD, this is our result. Now we will see the execution of the program. So I'll copy the program first. Now we will go to the Keel software. Maximize this. Go to project, new Vision project. I'll use the previously used project. Click on yes. Now search for the microchip device and click on the plus symbol and search for 8089 C51. Click on OK and click on no. So the target one is created. Now go to file, open new file and type your program here. I'll directly paste the program and I will save it. Okay, I'll save this program as, this program is finding the cube, so I'll write it as cube and I'll save this as with extension .asm. So save. Now you have to go to the target and click on this plus symbol and you will get source group 1. Right click on this and click on add existing files to source group 1. Now search your program, it is cube.asm. Select that, click on add and click on close. Now go to project, click on build target. So you are getting 0 errors and 0 warnings. Go to debug, click on start or stop debug session and then click on OK. Now our memory address is 8000H. So here we require only one memory window and here I'll type it as x colon 8000H. Okay, so at 8000H I have to give the input as FF. Fine. Now I'll check the output. So run. You are getting the output as FF02 FD. Okay, so we wanted the same output, that is FF at 8003, 02 at 8002 and FD at 8001. So this is our output. We'll try one more example here. Okay, I'll stop it. Go to debug, start and stop session. Okay, I will give the input as 08. We'll see what will get the output. So go to debug and run. So here the output will be what? 002000. So here the output is correct, that is the cube of 8 will be it will be 002000. Okay, so here like this it will be 00 02 and 00. Okay, this is the output. Hope you have understood the program. Thank you.